Hello friends, welcome to Joy of Life once again. So today we are going to solve another medium problem from Leetcode. The problem number is 236. The name of the problem is lowest common ancestor of a binary tree. A very common interview question. So let's look at the description of the problem. Given a binary tree, find the lowest common ancestor, also known as LCA, of two given nodes in the tree. So according to the definition of LCA on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendant. Okay, where we allow a node to be descendant of itself. So let's look at a few of the example given over here. So here we have a binary tree. Remember, this is a binary tree and not a binary search tree. So the property that we see in a binary search tree is not present over here. So we are given with two nodes 5 and 1, and we need to find the common ancestor of it. So if we see in the tree, 5 is here, 1 is here, and they share a common parent which is 3. So 3 is our LCA, and you can see here that 3 is the answer as well. Okay, so let's see another example. So here again we are given with a similar kind of tree wherein we need to find 5 and 4 in the tree. So you see 5 is present over here and 4 is here. But as you see over here that they do not have a common parent. So 5 here acts as a parent of 4 as well as 5. So 5 would be our answer over here. So you can see here, right? So if you see the description of the problem given, so it says where to be a descendant of itself. So in that case, in this case that you see over here, uh, we see that 5 is a descendant of itself. So you can see over here that 5 is a descendant of itself, right? So let's look at the solution, and as I always say that before you look at the solution, do give it a try yourself, and you can pause the video here and then you can resume or come back to it whenever you want. So let's look at the solution. So I've copied the tree from the example over here. So I'm using this same tree, and we are going to see how we can come up with various inputs. So first we will try with P equals to 5 and Q equals to 1. So most of these problems, when we try to identify something in the tree, the first thing that comes to my mind is a recursive solution. So when you see a tree, what you basically see is that we start traversing from the top, and from top you always have two choices to make, either to go left or to go right, and identify what we are looking for. So similarly, we will also be given the root of the tree. We are given with the root of the tree, which is 3. And as you know that we are talking about a recursive solution over here. So we will see at a recursive approach on how we come up with the solution. So let's say we have a function wherein we will receive the root and we will receive both P and Q. So this is my function. So basically what is my first lookout, or the first breaking condition would be, so if you see that the root's value is equals to P's value, so this we can say that we have reached a node, provided just the assumption over here that all the values are unique in this tree. Okay, so root's value is equals to P's value. So P's value is 5, and currently my root is at 3. So if my root value is equal to the value of P, or my root's value is equals to the value of my Q. So when either of this condition matches, we know that we have found one of the node that we are looking for. In that case, we'll be returning the root, right? But in case of 3, we see that it's not matching. So what we'll straight away start doing is we'll start calling this function, this function itself again. So what we'll be calling this with? We'll calling this with the left part of the tree and PQ, the thing that we are looking for. And at the same time, we'll also call in a function, in the same function again, the right part of the tree with P and Q. So what happens is when 3 is not matched, first we start exploring the left side of the tree, and then we start exploring the right side of the tree. So we straight away look for these things, and whatever we get, we store them in, say, left and right, right? So what happens is, so first this function is executed first, as it is before the right function, right? So this call gets invoked with 5. So my first call, so let me put it over here. There we have shortage of space. So we have called with 3. Now we have called with 5, and we see that this condition is satisfied now. So what happens is 5 is returned. The node 5 is returned to its caller, which is the same instance of the function, and 5 is returned. So 3 gets a return over here, that is, it gets a 5 over here, right? And then what happens is we call the right side of the tree. So the right side of the tree is called with 1. And again, this condition is satisfied. So this time we have called it with 1. And this also got satisfied. So I got a 1 from here. So the invoking function 3 got a return of 1. So it got return from both the sides, right? So what does that signifies? If so, I could easily say that if my left not equals to null and so if both conditions are satisfied, that if my left is not null and my right is also not null, means I am sitting at a node wherein I have a node that I'm looking for on my left side, I have a node that I'm looking for on my right side. So this is the node, that is my answer, right? So I'll be returning the root from here. So what does 3 returns? 3 returns itself to the main function, right? And that is our answer. Okay, so this is how it goes. So this is the algorithm, but there are edge cases to it as well. So we saw a very easy case wherein the nodes that we are looking for was at the first level itself. So let's say that we are looking for a node which is pretty much deeper. So say I am looking for P equals to 6 and Q equals to 4. So this is the node that I am looking for. These are the two. So in this case, my answer is actually 5. So they have the common parent, which is 5. So what happens is a call goes a call goes with 3, right? So what happens is 3 again invokes a function with 5, right? Because left is called first and then we call the right? So let's look at it. So 3 calls a function, 3 calls with 5, right? And 5 calls it again with its left. So 5 calls the 6, and when 6 is called, this condition is satisfied. So 6 is returned over here, and 5 receives from the left side of uh, it receives a 6, right? Now what happens? 5 call its right, so it calls with 2. It calls 2, and what does 2 do? 2 straight away calls 7. And so this condition is not matched, right, in these cases. So 7 calls with null. So we will introduce a condition over here that if root is null, then return null. So a null is returned from here, right? So 7 receives a, so left of 7 receives a null. Now 7 calls with its right. So again it hits a null. So it returns a null. So the right of 7 also receives a null. So you can see here that so you can see here that 7 got null from both ends. So if this condition is not matched, what I can say is I will return a null if no conditions are matching over here. So what does 7 returns? So 7 does not get any match over here. So 7 returns a null over here. So left of 2, which was called with 7 over here, receives a null. Now the right is invoked of 2. So right of 2 is 4. And we see that it has matched. So what happens from here? 4 is returned. So the right of 2 returns a 4, right? So that means there one of the child that we are looking for is present under 2. So 2 is the node that we are dealing with. So we will introduce a condition over here if left not equals to null. So here basically we have checked if both are not nulls, but if left is not null, so I can return my left only, return L. Similarly, if my right is not null, I will return my right. So at 2, what we see is the left is null, but right is 4. So this condition is false. Right is not null. Right has having a value 4. So I return to 6 with a 4, right? So sorry, not to 6. Return to 5. So 2 receives a 4 on its right. So what it does, it sends back to its caller a 4. So the right of 5 receives a 4. So you can see over here what happens is now the 5 who has invoked this function has got both left and right. None of them is null. So it will return 5. And when this condition is matched, so 5 is returned to the main function. So what happens is 5 returns himself to 3, and 3 returns what it got from 5 is 5 to the main function. You can see over here how we can find the descendant node easily between the nodes. So let's take an example now when p equals to 5 and q equals to 4. So in this case, this is p, and this is q. And the answer to this is 5. And we will see that how this algorithm fits this problem. So what I'll do quickly for you is get this tree down so that we can refer it and have some space for us. Yeah. So what happens is our call starts from 3 again, and 3 has a left and 3 has a right. So I don't have the answer for them yet. So what do? I call my left, I call 5. And straight away I see that this condition this condition is matched. So what do I return from here? I return root from here. So when 5 is matched, what I return to my 3? I return 5 to him. So the left is set at 5. Okay. Now what happens? Now 3 calls 1, right? So we will see the answer in the left and right of 1. So what 1 does is 1 calls 0. We'll see the left and right of 0 because they are not matching. This condition is not matched, this condition that we are talking about here. So 0 calls with null and he sends back a null. So the left is set to null. Then 0 call its right, which is also null. So he also sends back a null. So it gets a null from both the ends. So when null is received for both the ends, so none of these conditions that we have is satisfied. So a null is returned. So what happens is 0 sends back a null to its caller 1. So he gets a null over here. The left gets a null. So now 1 calls his right to see what it can, and 1 is done exploring its left. So it will start exploring its right. So it will also receive 2 answers, left and right. So 8 will call its left, which is null, and its right, which is null. So from both ends, you will get a null. So what you will do to its caller, who is 1, it will send back a null because both are null. So the right becomes null. So when left and right both are null, so what happens is I send back a null to my caller. So one's caller was 3, I send back a null. So what you can see over here that 3, my root node, has received 2 nodes. One is 5, one is null. So left, when left is not equals to null, this condition is satisfied and left is returned. So it returns to its caller, which is the main function. It returns a 5 to its caller because that is our condition. And here 5 is our answer as well. So you can see here how we are just simply branching out and we are expecting result from both the ends. So let's quickly look at an extreme example using this one. So let's say we are trying to locate 6 and 8. So we'll quickly go through this one. P equals to say 6 and Q equals to 8. And here our answer would be 3. So you will see how 3 is received from both the ends. So say the function is called with 3, so I'll be expecting a left and the right answer, but I don't know the answer yet. So what happens? A call is started with 5. So 5 will also have a left and a right answer because 5 is not equals to 6 or 8. So 5 calls it with 6. And since it's a match, so 6 is returned over here and 6 gets set on my left. Right? I get an answer from my left. So now 5 calls its right, which is 2. I don't know the answer for them. So I'll wait for the answer. So 6 is one of the answers that we have got. 6 is nothing but is our P. So 2 invokes 7. 7 has a left and a right. We don't know the answer yet. So 7 calls 7's left child is null. So 7 calls with null and gets a null. So it sets the left as null. And 7 calls its right with a null and it gets a null. Since both of them are null, so 2's left gets a null. Now 2 calls with makes the call with its right. So it has 4 on its right. We don't know the answer again for left and right. So 4 again calls with its left child and right child, and unfortunately both of them are null. So it receives a null at both, right? And it sends back a null to 2. Since 2 has, so you can see over here, since 2 has both, 2 gets both null answers from left and right child. So 2 sends back a null to 5, its caller. So 5 sees that one of its edge is null and one is not. So it returns the non-null edge to 3. So 3 receives a 6 on its left. Okay. And now the right part is pending for 3. So 3 calls. So let me draw the right part over here due to shortage of space. So 3 calls, the left is done. So 3 calls its right with a 1. We don't know the answer, so we'll wait for left and right. Again, the left is called with 0. We don't know the left and right. And right has 2 childs, both of them are null. So it receives null from both. And it sends back a null to its caller 1. So one calls its right, which is 8 and which is a match. So it receives the one, node 1 receives a 8 on its right. And since one of them is not null, and it returns the same back to its caller 3. So 3 receives 6 and 8 on its left and right. So immediately we know that this condition has been matched. This condition over here has been matched. And we will return 3 to the main function, which is our answer. So this is the entire algorithm that you see over here. It is the entire algorithm that you see over here, and we are going to put these as is in the code without any change. So let's head over to the editor. So what happens is, just as I told you, okay, so if root is null, then we are going to return a null. Okay, and the next condition that we know, it's root dot val is equals to p dot val, or root dot val is equals to q dot val. So either of the condition, when it matches, we return root, right? So this is what we are doing. So our node name is tree node, so we'll just use a left and a right. So we will call the same function, lowest common ancestor, with root dot left and pq. And similarly, we are going to call the same function again for the right as well. So let's say this is right. And we can simply say if left not equals to null. So when both are actually having the value, when p left not equals to null and right not equals to null, we can return the root. So if both so this is that node 3, so I have answers from both the edges, so I'll be returning that. So else if we can say left not equals to null, then return left, else if right not equals to null, return right. And if nothing matches, means I don't have answer from anyone, I am just going to return a null. That's it. So this is the solution. And if you take a peek on what we did exactly the same thing that we have seen on the Leetcode. So let's run this code. So this is a very classic example of a recursive function. This is also a very common interview question. So let's do a submit and see for a broader range of test cases how it goes. So yeah, we see that we are 4 milliseconds, which is 100% faster than all submission, which is pretty great. And we are just mostly using the stack space over here. So we are making calls, right? So as you have seen in the diagram that so 3 calls, 5 calls, 0 calls, something. So everything is getting stacked. Everything is getting stacked, and that is how this entire algorithm works. So I hope you liked the video and got the concept of what I was trying to uh, trying to say. Do share, like, and subscribe. It was good to get support from you all, and I'll be creating more videos on Leetcode. I'll also start exploring other platforms as well. There are HackerRank and many other platforms, even Geek for Geek. I'll try to solve and also try to come up with some of the algorithm and run you through how those algorithms works in down the line. So have a great day and see you soon again. Bye bye.